Hi everybody. So I'm very interested in energy storage. Now, energy storage is one of those things that raises fine examples of thinking inside the box. Every time you mention it, what people really do is they go straight to batteries, electrochemical batteries, and particularly lithium. And there's reams and reams of argument and tons of video on which is better, lithium or lead. Which flavour of lithium that's popular at the moment is better than another flavour of lithium? There are electrochemical batteries, well, they have their advantages, that's for sure. The main one being they're energy dense. That is, they'll store a lot of energy per kilogram of weight. And that's a huge advantage for lots of applications. But they bring with them a huge number of disadvantages that people basically ignore. For one thing, they're expensive. They're poisonous. Outside of lead, they're not recycled, they're just dumped. And some of them have a very nasty habit of burning everything to the ground to a greasy spot. So there's an awful lot of disadvantages that go alongside chemical batteries. Now, I'm a huge fan of gravity batteries. Gravity batteries are basically, you pull a rock up and let it go and it stores the energy. Now they have disadvantages as well. I mean, they're nowhere near as energy dense as an electrochemical battery. That is true. But they have an enormous amount of advantages that go along with them. I mean, the first thing is, it's a rock, so it's not poisonous. You don't have to dispose of it, it's a rock. All you've got to do is drag it up, and of course that makes it very cheap. It also means that they don't lose their energy, they store the energy forever. They don't wear out in the act of raising it and dropping it. They're 100% efficient. They've got this huge amount of advantages to them that outweigh electrochemical batteries like you wouldn't believe. Luckily, of course, the people who develop energy storage systems are well aware of this. And given the advantages of something like a weight, it turns out that it cost per kilowatt hour stored, gravity batteries are better than electrochemical batteries because the replacement cost, maintenance cost, purchase cost of electrochemical batteries makes a whole battery storage system for energy as a system pretty expensive. Whereas if you're just taking rocks and dropping them down a hill, turns out it's pretty cheap. And so although you can't store as much for each kilogram of rock, overall for the whole system it's cheaper. Of course, I'm being a bit glib to make a point. These systems are more complicated because one of the issues when you drop a weight is, well, it falls, and it falls without control. Without control, zoom, gone. What you need is some kind of control in there. Now, a friend of mine, he's a high school student from the Philippines, is working with a group of his friends, so that's Deal and his friends, and they're working on a gravity battery system and they're looking at the control. He wrote to me and suggested an escapement, and I thought, what a brilliant idea, because the escapement, controlling a falling weight, is as old as pendulum-driven clocks. It's an awesome mechanism to be looking at for one aspect of this problem. So I went and drew this up. As you can see, it is just a large escapement. The files, of course, are in Tinkercad, and I've made them freely available in the description below. Then what I've done is I've printed them out. So this bottom plate gets a bearing right in the corner, a couple of angles on it to hold it, the ratchet reel itself, it's a bearing that side and that side. The pendulum attachment there has a bearing in it, that's the escapement arm, and then the front plate has a bearing in there, and the whole thing just slots together. Okay, that's it slotted together, and you can see that the wheel has these spokes in this way. This is a pendulum, actually. Now, a pendulum's a really good way of controlling it because that gives an even time spread, obviously, but you could use a solenoid just as well if you wanted, but this is pendulum controlled, and this catchment arm is what stops it. So the weight's attached here, and the weight is pulling down on it, and as it pulls down on it, it wants to turn in that direction. But that arm has a little stop that stops that wheel turning anymore. As the pendulum swings in that direction, of course, it moves that arm, allowing this to move again. As this moves, that catches there, pushing the pendulum, imparting energy into the pendulum, that drops back down and stops again. So it's a jolting, stopping movement where we can time it using a pendulum. Now in a clock, of course, that tick is fine. It works just fine and doesn't really worry at all. It's something like this where you're wanting a smooth output. This is the basics of the control unit, controlled by a pendulum. Could be controlled by a solenoid, but it creates a jerky movement. What we might want to do is put a flywheel in there. There's a flywheel will take that jerking movement and even the movement out, and we've done that with flywheel generators before. The other thing we might want to do, of course, is to put gearing in there so that if we use a very heavy weight, then the gearing will take care of that heavy weight, because this will carry as much weight as it's physically able to. And that means it's a pretty much unlimited amount of energy it can store. But that would be the basics of a control mechanism, and all we have to do now is put the front plate on and tie on a weight. Okay, so there it is with the front plate on, tied to the bench. It's got a weight tied around the ratchet wheel there, and that is where the pendulum would go, or as I suggested, a solenoid switch. And all we have to do to make this work is push that. As we push it, you can see it rising there to push that arm out the way. Arm goes out the way. There you go. You can see that moving out the way and back down again. As it comes back down, this pushes it to push that back out of the way. Okay, I've attached a pendulum. Let's get it going. Isn't that awesome? I mean, it's an escapement from a clock, eh? So it's going to work, but it's awesome to see it actually work and controlling the fall of that weight. So this is a key and crucial component to a gravity battery. It's awesome! Look at this!
Oh, that's awesome!
This is an age-old mechanism, but it is an essential component to the control of gravity batteries. Of course, I did this for Deal and his friends who are working in the Philippines, as I said earlier, so they're more than welcome to this. I hope it's useful and helpful to them. For everybody else, everything I do is public domain, so you're quite welcome to take these files and do what you want with them. There are other components this would need. I mean, a one-way clutch with the freewheel with a weight that we did in the freewheel generator would be an awesome addition to this, because it will iron out that jerky movement and make for constant generation. But I think that's an essential component. I think other components we've actually done, I think if you put them together, then you're going to have a weight-driven gravity battery quite easily. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.